Welcome back to another exciting episode of Dave Does Math from Home. This is part 3 of our video series on volumes of rotation using the disk method. We're going to have another set of videos soon where we're going to talk about the other technique for finding volumes of rotation. That one has lots of different names. But in this series we're doing disks only, and I want to do a couple more examples, and then I will release you to do all kinds of fun homework problems. So for these examples I want to work with a relatively straightforward function. Let's do y equals x cubed, not cubed, y equals x squared. That's what I want to do. I'm going to do y equals x squared, which is fairly straightforward. It looks like this. I'm going to go on the interval from 0 to 3. So we'll end it here. This is the area we're dealing with. This time, I'm going to rotate it around this line. So I'm not going to rotate it around the x-axis or the y-axis. The line I'm rotating around is not an axis at all. I'm going to rotate it around the line x equals 3. So let's see how that changes this process. I need, first of all, to cut this thing. If I want to get disks, and in this case I do want to get disks, I have to cut it horizontally, which means when I rotate it, I'm going to get little disks this way, little horizontal disks, and the height of these disks is going to be dy. The radius of these disks is going to be very interesting, because this isn't just an axis thing anymore. We're going to have to think about the radius. So before we do this, let's establish that we've drawn a picture. Based on this picture, we can pretty reliably tell we're going to get regular old-fashioned disks, solid disks. There's no holes in the middle, so we don't have to deal with the volume of a donut. We're going to do the volume of a disk. And the volume of a disk, as always, is pi r squared h. And we already know what h is. H is dy, because getting these disks means horizontal slices. Horizontal slices of this thing means that dy is the height of our little disk. So we just need to figure out the radius, and then we can have our volume, and then we can integrate that volume to get the volume of the whole shape. The volume of the whole shape is going to be like a very pointy mountain or something. So to get this radius is going to be 3 at the very bottom. It's going to be 0 at the very top. And it's going to, as you go from the bottom to the top, the radius is going to decrease. I know that this distance from the axis, from the y-axis to the axis of rotation, this distance is always 3. And I know that this distance is always x, except x in this case is going to be the square root of y. So this distance, which is the radius of my disk that I want, this distance is going to be the whole thing, the entire 3, minus the square root of y. That's the whole piece minus the missing piece gives us the actual distance that we want. And we can verify that when y equals 0, we're going to have a radius of 3, the whole thing. And when y equals, up here at the top, this is probably something like 9. If x is 3 and this is x squared, then that should be 9. Way up here at the top, we should get a radius of 0. So 3 minus this x value should give us the correct radius we're working with here. So the volume of our disk is going to be a little bit of a mess. Pi times 3 minus root y squared dy, which we can simplify into pi times 9 minus 6 root y plus y dy. This is the volume of one disk. We need to integrate across the entire series of y values to get the volume of the entire shape. So the volume of our mountain should be, pi can stay on the outside, integral 9 minus 6 root y plus y dy. The bounds on this integral should go from, we need y values here because we're integrating on y. So the y values should be from 0 up to 9. This is the setup for the integral. I want to do one more example, and in the interests of time, I'm not going to evaluate this particular integral. If you're really, really interested in figuring out what the volume of this little mountain is, then I would encourage you to evaluate this integral on your own. You are certainly capable. I believe in you. It's not a difficult integral. It's just kind of a long, messy one. There's no tricks to it. It's just a lot of arithmetic, and I don't want to do arithmetic right now. So, feel free to evaluate this if you like. I consider the difficult part of this to be finished. I'm going to start doing another example. I'm going to use the same function for my second example. I'm still going to do y equals x squared from 0 to 3, which is still going to look like this. This time, I'm not going to rotate around the line x equals 3. I'm not going to rotate around the y-axis. I'm not going to rotate around the x-axis. I'm going to rotate around the line y equals negative 2. This will be my axis of rotation. So, to use the disk method here, we're going to have to cut this thing vertically. If you want to use disks, your slices always have to be perpendicular to the axis of rotation. So if your axis of rotation is a horizontal line, that means that vertical slices will get you the disks. So this is my vertical slice. When I rotate it around, it's going to have a little hole in it. So I'm not really dealing with the volume of a disk, I'm dealing with the volume of a donut, which is pi times r big squared h minus pi times r small squared h. So r big should be the volume from the top of your disk to the axis, and r small should be the inside little piece that's missing. R small is the radius of the hole that's punched out of your bigger disk. So we need to figure out what all these things are. R big is going to be this distance. This distance is y. I guess it's going to be the whole thing from top to bottom. It's going to be from here to here is y, from here to here is 2. So r big is going to be y plus 2. But I don't want it in terms of y. H in this case is going to be the width of our disks is going to be dx, a tiny, tiny little slice of the x-axis. So if h is dx, that means I need all of these other things to be in terms of x. So I can't use y plus 2. I need to use whatever y is. Y is x squared. So this will be x squared plus 2. that's my radius. H is dx. R small should be, R small is nice. R small is a constant, it's always 2. It's the size of the hole that I'm punching out in the middle. So that's nice. So the volume of my donut is pi times x squared plus 2 squared dx minus pi times 2 squared dx. And to get the volume of, I didn't even talk about what the shape looks like when you rotate it. This is going to kind of create another like sort of science fair volcano sort of shape. When you rotate it like this. It's going to be sideways though. So if you rotate your head to the side, you can kind of imagine this being like a science fair volcano with a huge hole in the middle. So the volume of this volcano will be pi. I can factor out and leave on the outside. I guess I should, before we do the volume of the volcano, let me simplify this volume of the shape a little bit. The volume of the donut. I can factor the pi's out in front. I can factor the dx's out in back. X squared plus 2 squared should be x to the 4th plus 4x squared plus 4 minus 4. So these pieces will cancel. And it's just the volume of the volcano now will be, pi is a coefficient, it can stay out front, it's safe. I need to integrate x to the 4th plus 4x squared dx. And I need bounds on the x-axis. X, I think, is going to go from 0 to 3. Once again, I'm going to leave this particular evaluation up to you. If you want to evaluate this integral and find out exactly what the volume of this volcano shape is, the sideways volcano shape, please do. I think it's good practice to evaluate that integral. I think that I personally don't need that practice. I'm going to end the video here. The homework for this section is an ordeal, so don't sleep on it. Definitely get started as soon as possible so that when you find the really hard questions that are like a terrible mess, kind of like the one we did in the last video, you can ask me questions about it and we can work through it together in a non-terrifying, easy to process sort of way. So definitely do that. I look forward to talking to you about it. Bye.